Mm. Okay. Um, jeez. Perimeter and area in the coordinate plane. We're gonna first start out just with some vocabulary. You've definitely seen some of these words before. The first word is polygon. Even though you've seen this, I highly doubt you could like just define it off the top of your head. The definition is it's a closed figure with straight sides. So that's the official definition in the most shorthanded way possible. Closed figure with straight sides. What does that mean? It would be like a square, closed figure, straight sides. Or like a triangle, closed, like all the sides connect, closes off, and straight sides. Or maybe like a pentagon, closed figure, straight sides. That's a polygon. So then what's not a polygon? Well, what is not a polygon would be like a circle. Doesn't have straight sides. It's closed, but it doesn't have straight sides. Or maybe an oval. Again, it's closed, but it doesn't have straight sides. Or maybe it has straight sides, but it doesn't close, like it's not, doesn't connect and close off. Or maybe it has some straight sides, but then some curved edges. This would be not a polygon. So for it to be a polygon, it has to have all straight sides and it has to be closed. When we name a polygon, we name it by the vertices or the corners. So we name it by these corners. When you name it, you have to go in order of the shape. You could either go clockwise or counterclockwise, but you have to say the letters in order. It just so happens for this polygon, it lands in alphabetical order, but that doesn't always happen, or it doesn't even happen normally. So we'll just start with A, B, C, D, E, and I'm just going around the polygon. Polygon A, B, C, D, E, and you name all the vertices. Corners. Something else to note, just make your life easier. The number of vertices or the number of corners is the same as the number of sides. So if you see this and it has 5 corners, then it also has 5 sides. So just looking at this without even drawing it, you know it's a pentagon because it has 5 corners. Drawing, you good? Do you need a pencil or anything? Or are you good? Okay. So then what else do we need to know? Down here, there's this chart. You do need to know like how to name a polygon based on the number of sides. You've seen this before since like elementary school. Like a 3-sided shape is a triangle. 4-sided is quadrilateral. 5 is a pentagon. 6 a hexagon. The one that people forget a lot is 7, heptagon. And for whatever reason, they like to put the oddball ones on testing. So 7 is heptagon. 8, octagon. That would be a stop sign. 9 is another one that people forget. Nonagon. 10 is decagon and 12 is dodecagon, and then any more than that you name based on the side. So for example, like 14-sided shape would be a 14gon, or like a 38-sided shape would be a 38gon. So on. I think there is a name for that. Let's see. I don't know why they didn't put it in the chart. 11-sided. See, I'm Googling shape or polygon name. It is hendecagon. I guess we could add it. So 11 is a hendecagon. Desmond, can you take your headphones off and put them in your backpack, please? Thanks. Okay. Next couple vocabulary words is convex polygon versus concave polygon. So this is convex, this is concave. The definition for this is very technical. A polygon is convex when no line that contains the side of the polygon contains a point in the interior of the polygon. Anyways, how I like to remember is concave has a cave. And so if it has a cave, it's concave. If it doesn't have a cave, it's convex. The technical definition is talking about when you draw a line that includes the side, it passes through the shape. But I like to remember this way. Concave has a cave, convex doesn't. And then the last two words that we need to know that are new is regular polygon, and irregular polygon. Regular polygon is very popular, and if you read this in a problem, you just think it's like unimportant, but it's actually so important. So they'll say like a regular pentagon, and it just seems like, okay, a regular pentagon. But what it actually means is that it's the most perfect shape. So we're gonna try to draw the most perfect hexagon right here. Perfect meaning all the sides are the same length and all the angles are the same. So a regular polygon means that all the sides are the same length, and when all the sides are the same length, all the angles are the same as well. Or vice versa. If all the angles are the same measure, then all the sides will be the same. So all sides are equal, and then all angles are equal. So really it should be called like a perfect polygon. I don't know why they call it regular, because it's actually perfect. And then for an irregular polygon, it just means the sides aren't equal and all the angles aren't equal. So for example, here is also a hexagon. It has 6 sides, but all the sides aren't equal. And then subsequently, the angles aren't equal either. There might be some angles that are the same, but not all the angles are the same. Okay.
So all the sides are not equal for you.
So all the sides aren't equal. There might be some that are equal, like I don't want to mark it up too much, but like these sides could be equal, or like these sides could be equal to each other, but not all 6 are the same length. Whereas here, all 6 are the same length and all the angles are the same. And then here it says classify each polygon by the number of sides and tell whether it's convex or concave. So for this shape, we just count the number of sides, 1, 2, 3, 4. So it has 4 sides. So that would be a quadrilateral. And then convex or concave, well, it has a cave. So therefore, it is concave. And for this one, 1, 2, 3, 4, 5, 6 sides. 6 sides is a hexagon. It doesn't have a cave, so it's convex. Okay, so that skill right there, we're going to do that same thing here. I'm going to have you try it. So you try it. Classify the polygon by the number of sides. So count the number of sides. Use the chart if you need to classify it. And then tell whether it's convex or concave. I'm going to freeze mine. I'm going to put my answers in and then we'll compare. So you're counting the number of sides and then identifying it. Seeing whether it has a cave or not. And then classifying it. Okay, I'm gonna move to the next page. Okay, over here, now it starts introducing perimeter and area. So we're going to be reviewing perimeter. Perimeter, as you may remember, is the distance around a shape, distance around a shape. So for perimeter, you don't really need to remember an equation. You just need to know that you have to add up all the sides of that shape. And then area is the space inside a shape. Space inside a shape. And there is an equation for area of each type of shape. So in this chart, these are the shapes we're going to be working with today: triangle, square, rectangle, and parallelogram. So just very basic shapes. So for perimeter, you just add up all the sides. For area of a triangle, you take the length of the base and the perpendicular height. You multiply those and then multiply by 1/2 or divide by 2, same thing. For a square, it's just base times height, length times width, which will be the same number. For a rectangle, it's length times width for area. And then for parallelogram, it's base times the perpendicular height. You multiply those two and you get the area of a parallelogram. Okay, and then when you have that done, we're going to flip to the next page. You just flip your page. And I'm going to hear you guys all flip. I'm going to flip mine as well. Then on the back here, now we're going to do some practice here. For the first four, it says, classify the polygon by the number of sides. Tell whether it's convex or concave. Now, I know a lot of you can do this independently. For the sake of just like time, I'll just do it with you guys. So I'm going to count the number of sides. So we have 1, 2, 3, 4. So that would be a quadrilateral. And it does have a cave there. Cave. So therefore, this is concave. Okay, this one, 1, 2, 3 sides, is a triangle. You might have recognized it as a triangle. Yes, it's a triangle. It doesn't have a concave, so it is convex. For number 3, 1, 2, 3, 4, 5, 5 sides, that is a pentagon. No cave, so it's convex. Number 4, counting the sides, 1, 2, 3, 4, 5, 6 sides. So this would be a hexagon. It does have a cave, so it is concave. Okay, so for the next problems, it says find the perimeter. So for these specific problems, we're going to be finding just perimeter. And then for the other 4 on the other page, we're doing area. So we're going to switch skills, but starting with perimeter, which perimeter is the distance around the shape. So what we need to do is find the length of each of these sides. Now what's nice is when you have a horizontal or vertical line, you can just count the units. You don't have to like solve it per se. So for the first example here, we can find this length just 1, 2, 3, 4 units. And in a rectangle, like opposite sides are equal. So if this is 4, this is 4. And then for this, 1, 2, 3, 4, 5, 6, 7 units. And opposite sides are the same, so we have 7 over here. And then to find the perimeter, we just add up all the side lengths. So perimeter is 4 plus 7 plus 4 plus 7. 11 plus 11 is 22 units. And that is all. It's just units, not units squared or anything, because it's just a length. So it's just units. Okay, number 6. Finding the perimeter of the shape. Let's see, 1, 2, 3, 4 units. 1, 2, 3, 4 units. Here, it's a square, like opposite sides are going to be, 4. Okay, so perimeter here, we just need to add up 4 plus 4 plus 4 plus 4. Adding up all the sides. 4 plus 4 is 8. Bring this down, 4 plus 4 is 8. Perimeter equals 16 units. Okay, number 7, we're finding the perimeter of this triangle. For this side, we can count units 1, 2, 3, 4, 5 here. This 1, 2, 3, 4, 5, 6, 7, 8 units. For the diagonal one, though, we can't count units. Like the diagonal square isn't 1, so we actually have to solve for this side. There's a couple different ways we can do it. We can use distance formula, but an easier way to do it is to use that Pythagorean theorem method that we learned. So we have a right triangle here, so we can use a squared plus b squared equals c squared to find this length here. So this would be our a and b, and then this is our c. So we can do 5 squared plus 8 squared equals c squared. 25 plus 64 equals c squared. 25 plus 64 is 89. Square root, and then c is 9.43. So 9.43 right here. And then to find the perimeter, we add up those values. 5 plus 8 plus 9.43, and the perimeter is 22.43 units. So the first two are very like middle school level, and this is more high school. The actual standard for this says finding the perimeter of a shape on a coordinate plane where you have to solve for up to 2 sides. So we just solved for one side, and then the next one we're going to solve 2 sides. Okay, so then for number 8, we graph the shape. For this side, we can count the units 1, 2, 3, 4, 5 units. But for the diagonals, we can't quite count. So I'm going to sketch out a right triangle here. So that way I can use Pythagorean theorem to find that distance. So I got 3 and 1, 2, 3, 4 right there. And then I'll sketch out a right triangle here too. And this will be 2 by 1, 2, 3, 4. Let me get there. Okay, so to find this length here, I'll do 4 squared plus 3 squared equals c squared. 16 plus 9 is c squared. 25 equals c squared. Square root, and c equals 5. This 5 is this right here, so that's 5 units. And then for the next one, 2 squared plus 4 squared equals c squared. Square root, and c equals, comes out to decimal for this one, 4.47. So this here, 4.47 is this length, 4.47. And then the last step in finding the perimeter is adding up those values. So perimeter equals 5 plus 5 plus 4.47. Add those 3 values and you get 14.47. And that is like the high school level geometry. Actually, a lot of times on testing, you'll see more of this style, but we'll work up to that. Okay. Then on the next page, we're doing just area. And area is actually a little bit less work than perimeter, to be honest. So moving over to the next page first. So these ones, it just wants area of the polygon. So for each of these shapes, there's a different equation. So for area of a triangle, its area equals 1/2 base times height. And for this triangle, we can use this as a base, and this is the height, which is nice. 1, 2, 3, 4, 5. So that's 5. and then the height is 1, 2, 3 units. And then we can plug those into the equation. Area equals 1/2, base is 5, height is 3. And then we can multiply those three numbers. There's different ways that you could solve this. I know some of you know this, some of you might not, but there's actually a fraction button on here, so you can plug fractions right into here. So like 1/2, you can use a fraction button 1/2, like that, times 5 times 3. It gives you 7.5, or if you want to turn this into a decimal, F to D right here, second this, and then we get 7.5. So the answer to this is 7.5 units. Units squared now because we're working with area. So that's how many squares are in that triangle. Okay. Continuing, another triangle, area equals 1/2 base times height. You could use any of these sides for bases. However, I'm going to use one that like makes my life easier. And so this one is just a horizontal line, and I can count those units. So 1, 2, 3, 4, 5, 6, 7. So the base, 7. And then I need height. So I need perpendicular height from the bottom to this top corner. So this line right here is the height. 1, 2, 3, 4, 5, 6, 7. So the height is 7 as well. So area equals 1/2. Base is 7. Height is 7. And then you plug this into a calculator and it comes out to 24.5 units squared. It takes forever to focus on this camera. There we go. Okay. 13 shows a square. Area of a square is just like base times height, length times width, however you want to think about it. So this is here 3 units, 1, 2, 3. 1, 2, 3. Area equals 3 times 3. Area equals 9 units squared. You could even count the squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9 squares in that shape. And last one we're doing together is number 14. It's a parallelogram, meaning that the opposite sides are parallel and equal. The area of a parallelogram is just base times height, this being the base, and then the height is perpendicular height. So our perpendicular height is 2 units. The base is 1, 2, 3, 4, 5. Area equals 5 times 2. Area equals 10 units squared, like that. Okay. So what I'm going to have you do now is you're going to get your laptops and do homework 1-4 on Schoology. You'll likely be able to finish it by the end of class because it does go pretty quick. So just grab a laptop, log in, go to homework 1-4. I will also pass out graph paper because you may need to graph points on your homework, so I'll pass that out.